It is not allowable to use a 100% rated 400 amp breaker with 380 amp rated wiring. For 100% rated circuit breakers, the overcurrent protection device must be rated at or below the ampacity of the cable. In the given scenario, the cable is rated for 380 amps, so the overcurrent protection device must be rated at 380 amps or less. To understand why this is the case, it is important to delve into the fundamental principles governing electrical circuit protection and the specific requirements for 100% rated breakers. The primary purpose of an overcurrent protection device, such as a circuit breaker or fuse, is to protect electrical conductors from overheating and potential damage due to excessive current flow. This excessive current flow can result from various factors, including overloads, short circuits, and ground faults. When the current in a circuit exceeds the ampacity of the conductor begins to heat up. If this overcurrent condition persists, the conductor's insulation can degrade, leading to insulation failure, arcing faults, and potentially a fire. The ampacity of a conductor is the maximum amount of current, in amps, that the conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This rating is determined by factors such as the conductor's material, size, insulation type, and the ambient temperature in which it is installed. The National Electrical Code, or NEC, provides detailed tables and guidelines for determining the ampacity of various conductors under different installation conditions. These tables take into account factors such as the number of conductors in a raceway, the ambient temperature, and the type of insulation used. The NEC specifies that overcurrent protection devices must be selected and installed to protect conductors in accordance with their ampacity. This means that the rating of the overcurrent protection device should not exceed the ampacity of the conductor it is protecting. In general, standard circuit breakers and fuses are designed to trip at 80% of their rated current when subjected to a continuous load. This means that a 20 amp circuit breaker, for instance, is designed to trip when the current reaches 16 amps continuously. This 80% rating factor is built into the design of these devices to account for variations in manufacturing tolerances, ambient temperature fluctuations, and other factors that can affect their performance. However, 100% rated circuit breakers are specifically designed and tested to carry their rated current continuously without tripping. These breakers are typically used in applications where the load is expected to be continuous for extended periods, such as in industrial or commercial settings. Because 100% rated breakers are designed to carry their rated current continuously, they must be applied with extra caution to ensure that the conductors they are protecting are adequately sized to handle the full load current. The NEC provides specific requirements for the application of 100% rated breakers. These requirements are intended to ensure that the conductors are protected from overheating and potential damage. One of the key requirements is that the overcurrent protection device must be rated at or below the ampacity of the conductor it is protecting. This means that if a 100% rated breaker is used, the ampacity of the conductor must be at least equal to the rating of the breaker. In the given scenario, the cable is rated for 380 amps, while the 100% rated breaker is rated for 400 amps. This means that the breaker is rated to carry more current than the cable is designed to handle continuously. If the breaker were to allow 400 amps to flow through the 380 amp rated cable continuously, the cable would likely overheat, potentially leading to insulation failure, arcing faults, and a fire. Therefore, it is not permissible to use a 100% rated 400 amp breaker with 380 amp rated wiring. The overcurrent protection device must be rated at 380 amps or less to ensure that the cable is adequately protected. It is important to note that the NEC allows for certain exceptions to the general rule that the overcurrent protection device must be rated at or below the ampacity of the conductor. However, these exceptions are typically limited to specific situations and require careful engineering analysis to ensure that the conductors are adequately protected. For example, the NEC permits the use of the next highest standard overcurrent device rating in certain cases where the calculated load current does not correspond to a standard overcurrent device rating. However, This exception is subject to several limitations, including the requirement that the next highest standard overcurrent device rating does not exceed 800 amps and that the conductor is protected against overload in accordance with other NEC requirements. In addition to the NEC requirements, it is also important to consider the manufacturer's instructions and specifications when selecting and installing overcurrent protection devices. The manufacturer's instructions provide valuable information about the device's performance characteristics, limitations, and proper application. It is essential to follow the manufacturer's instructions carefully to ensure that the device is installed and operated safely and effectively. In summary, the use of a 100% rated 400 amp breaker with 380 amp rated wiring is not permissible because the overcurrent protection device must be rated at or below the ampacity of the cable it is protecting. The NEC provides specific requirements for the application of 100% rated breakers, which are intended to ensure that conductors are protected from overheating and potential damage. It is crucial to carefully consider these requirements and follow the manufacturer's instructions when selecting and installing overcurrent protection devices to ensure electrical safety and prevent potential hazards. Let's delve a little deeper into the NEC to further clarify the code requirements. NEC Section 240.4 Protection of Conductors outlines the general requirements for protecting conductors against overcurrent. It states that conductors shall be protected against overcurrent in accordance with their ampacities as specified in Section 310.15. Section 310.15 provides the ampacity tables for various types of conductors, taking into account factors such as conductor size, insulation type, and insulation conditions. As previously mentioned, the NEC allows for some exceptions to the rule that the overcurrent protection device must be rated at or below the ampacity of the conductor. One such exception is found in Section 240.4b, Overcurrent Protection for Specific Conductor Applications. This section provides specific rules for protecting conductors used in certain applications, such as motor circuits, transformer circuits, and capacitor circuits. However, these exceptions are carefully defined and are subject to specific limitations. For example, Section 430.52 provides rules for the overcurrent protection of motor circuits. These rules allow for the use of overcurrent devices with ratings higher than the conductor ampacity in certain cases, but only to facilitate motor starting. The overcurrent device is intended to protect the motor against short circuits and ground faults, while a separate overload relay is used to protect the motor against overloads. Similarly, Section 450.3 provides rules for the overcurrent protection of transformer circuits. These rules allow for the use of overcurrent devices with ratings higher than the conductor ampacity in certain cases, but only to accommodate the transformer's inrush current during energization. The overcurrent device is intended to protect the transformer against short circuits and ground faults, while a separate overload device is used to protect the transformer against overloads. In addition to the NEC requirements, it is also important to consider the listing and labeling of electrical equipment. Electrical equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, has been tested and found to comply with applicable safety standards. The listing mark on the equipment indicates that it has been evaluated for its intended use and that it meets the minimum safety requirements. The NEC requires that electrical equipment be used in accordance with this listing and labeling. This means that equipment should not be used in a manner that exceeds its rated capacity or that is not in accordance with the manufacturer's instructions. When selecting overcurrent protection devices, it is important to choose devices that are listed for the intended application and that have sufficient interrupting capacity to safely interrupt the maximum available fault current at the point of installation. The interrupting capacity of an overcurrent device is the maximum amount of fault current that the device can safely interrupt without failing or causing damage to the electrical system. The available fault current at a given point in the electrical system depends on factors such as the size of the utility transformer, the impedance of the conductors, and the presence of any fault current limiting devices. It is essential to perform a short circuit study to determine the available fault current at each point in the electrical system and to select overcurrent protection devices with adequate interrupting capacity. In addition to selecting overcurrent protection devices with adequate interrupting capacity, it is also important to ensure that they are properly coordinated to minimize the extent of any outages caused by faults. Coordination involves selecting overcurrent devices with appropriate time current characteristics so that the device closest to the fault will trip first, isolating the fault and minimizing the impact on the rest of the electrical system. Proper coordination requires a thorough understanding of the electrical system and the characteristics of the overcurrent protection devices being used. It is often necessary to use specialized software tools to perform coordination studies and to select the appropriate overcurrent devices. Furthermore, consider the impact of ambient temperature on conductor ampacity and breaker performance. High ambient temperatures can reduce the ampacity of conductors, as higher temperatures lead to increased resistance and heat generation. Similarly, high ambient temperatures can affect the tripping characteristics of circuit breakers, potentially causing them to trip at lower current levels. The NEC requires adjustments to conductor ampacity for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. Correction factors are provided in NEC Table 310.15 to account for different ambient temperatures. Likewise, circuit breaker manufacturers often provide information on the impact of ambient temperature on their breakers' performance. When applying 100% rated breakers, it is crucial to consider the impact of ambient temperature and to make appropriate adjustments to conductor ampacity and breaker ratings. Regularly inspect and maintain electrical equipment, including overcurrent protection devices, to ensure its proper operation. Over time, circuit breakers can become damaged or worn, leading to reduced performance or failure. Regular inspection and testing can help identify potential problems before they lead to more serious issues. The NEC recommends periodic testing of circuit breakers to verify their proper operation. Testing should be performed by qualified personnel using appropriate test equipment. Furthermore, ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it is essential to have the knowledge and skills necessary to perform the work safely and correctly. Qualified electricians are trained in the NEC and other applicable standards, and they have the experience to identify and address potential hazards. To summarize, always adhere to the NEC manufacturer's instructions and best practices when selecting, installing, and maintaining overcurrent protection devices. Prioritize electrical safety and consult with qualified professionals when in doubt.